The proposed 5-layer nested model for AI design and validation serves as a systematic guide for the assessment and validation of AI applications and workflows. This model is inspired by XAI-QB, extending it to include prototypical questions from a regulatory and domain perspective. The nested model consists of 5 layers: regulation, domain, data, model, and prediction. It addresses issues that AI practitioners face daily and aligns with regulations, improving fairness, trust, and AI adoption. The model also facilitates the identification of appropriate evaluation methodologies by identifying unique threats within each layer, mitigating inherent tensions between technological innovation and regulatory imperatives. It encourages shared accountability among stakeholders and provides prescriptive guidance for determining appropriate evaluation approaches. The model promotes fairness and safeguards against discrimination, and it addresses concerns about fairness, trust, and the alignment of AI models with existing regulations. The authors argue that the technical layer cannot be addressed without addressing regulatory requirements, such as AI transparency. They also present 2 preliminary case studies, including researchers who aim to develop reliable, wise, and trustworthy human-centered AI through ethical and theoretical guidelines with management strategies or software engineering practices. These include audit trails to enable analysis of failures, software engineering workflows, verification and validation testing, bias testing to enhance fairness, and even explainable user interfaces. The authors believe that the proposed model for AI design and validation is the first of its kind, and it offers much-needed overlap and grounding, facilitating the design and validation of AI applications and workflows, and increasing fairness, trust, and AI adoption. The proposed 5-layer nested model for AI design and validation is an innovative approach to ensure that AI applications and workflows comply with ethical, technical, and regulatory requirements. This model integrates the principles of explainable AI, XAI, and human-computer interaction, HCI, emphasizing the importance of user-centered explainability in AI development. The first layer, regulation, focuses on making the AI workflow compliant with ethical and technical regulations. This includes specifying ethical and technical rules, categorizing them, and identifying key stakeholders involved in the AI workflow. The domain layer ensures that the process is within the scope of the domain, requiring domain experts to list out requirements, potential risks, and pre-existing assumptions. The data layer aims to explain the data by summarizing and analyzing it, providing insights into data limitations, biases, and domain knowledge. It involves both ML practitioners and domain experts, who collaborate to identify and mitigate bias using tools like IBM's AI Fairness 360 library. The model layer explains the inner workings of the model, its parameters, and their meanings, focusing on interpretability and performance trade-offs. Finally, the prediction layer ensures that the AI model's predictions are accurate and reliable, considering aspects such as model complexity, overfitting, and underfitting. This nested model supports specifying requirements for building AI applications and identifies opportunities for collaboration between the HCI and AI communities, industry practitioners, and academics to advance the field of AI. It also helps to satisfy regulatory requirements, particularly those set by the EU, which emphasizes the importance of explainability in AI systems. The proposed model serves as a valuable tool for understanding user requirements for XAI, ensuring that AI upholds broader values such as accountability, human rights, and sustainable innovation. The prediction layer of the nested model aims to explain the reasoning behind a particular prediction, including how certain inputs affect the prediction, whether the reason is sufficient for the conclusion or decision, and what variables are involved behind the prediction. This layer helps answer questions such as what factors contribute to the importance of a parameter, objective, or action, when a parameter, objective, or action was evaluated or rejected, and what are the consequences of changing a decision or adjusting a parameter. The nested model prohibits entering further sublayers until the goal of the previous layers has been achieved, ensuring that the user can proceed to the next layer only after accomplishing the specific goal of the current layer. This model conforms to regulatory guidelines, addressing challenges in AI workflows and enabling AI to be compliant, trustworthy, accountable, non-discriminatory, and transparent. The outcomes of the nested model include defining a common baseline for the adoption of AI in real-life use cases, acting as a common intersection between regulatory authorities, (ZE), and AI practitioners, reducing the chances of AI implosion by addressing issues and potential threats with each layer, and evaluating AI workflows through both evaluation metrics and key requirements of regulations. To implement the nested model, regulations need to be defined into ethical and technical aspects. Ethical regulations focus on promoting values, principles, and norms associated with responsible AI development and usage, while technical regulations focus on specific technical aspects and requirements to ensure the responsible and safe use of AI systems. The implementation involves steps such as defining regulations and key requirements, categorizing them into ethical and technical requirements, addressing ethical requirements first, and then mapping technical key requirements to sublayers and addressing them using appropriate methodologies. A use case is provided, illustrating how the European Union's requirements for trustworthy AI can be implemented using the nested model. The key requirements are listed, categorized into ethical and technical aspects, and addressed accordingly. This approach ensures that AI systems meet the necessary standards and regulations, promoting transparency, accountability, and trustworthiness. The EU trustworthy AI requirements are categorized into ethical and technical requirements, encompassing human agency and oversight, diversity, non-discrimination, technical robustness, fairness, and transparency. A nested model for AI design and validation is proposed, consisting of regulation, domain, data, model, and prediction layers. The regulation layer ensures compliance with AI workflows, addressing regulatory threats such as inappropriate regulations and operational burdens. The domain layer sets boundaries on processes within the domain's purview, while the data layer summarizes and analyzes data to provide insights. However, potential threats exist at each layer, including inappropriate regulations, no domain oversight, biased data, non-interpretable models, and lack of transparency. The model layer explains the inner workings of the model, including parameters and interpretability, while the prediction layer explains the reason behind predictions and the variables involved. Failure to consider prior knowledge, incomplete data, and biased data can lead to potential threats at the data layer. Similarly, non-interpretable models and improper model validation can occur at the model layer, and lack of transparency can arise at the prediction layer. A concrete example is provided, analyzing Google's AI model for detecting retinopathy. The model failed due to disparities between training data and real-life data, highlighting the importance of addressing ethical and technical requirements during development. The FDA approval process is insufficient for AI applications in healthcare, and additional oversight mechanisms are needed to ensure AI applications are clear, safe, and efficient. The proposed framework addresses the key requirements of ethical and technical trustworthy AI, providing a comprehensive approach to designing and validating AI systems. By identifying potential threats at each layer and addressing them through appropriate methodologies, accountability can be achieved. The FDA's traditional regulatory framework is not well suited for AI technologies, leading to significant gaps in ML workflow development. It is crucial to involve domain experts throughout the evaluation process, ensuring constant feedback and consultation. Image augmentation and training data from the same device used in production can help mitigate the threat of biased training data. Moreover, models should be validated on real-life retina images, and end-user XAI techniques should be adopted to explain predictions to users according to their background. The FDA is addressing regulatory issues raised by AI in healthcare, but more comprehensive and transparent processes are required to handle the dynamic nature of AI. The integration of user-centric XAI approaches and collaboration with domain experts can enhance the evaluation of AI systems. This prioritizes understanding user needs, identifying explainability needs, and capturing domain knowledge. The Zillow Group, Inc. house price forecasting model failure highlights the importance of considering potential limitations and risks of AI models in critical business decisions. A lack of transparency in decision-making and proprietary models can lead to significant losses. Instead, open-source models and XAI can enable transparency in decision-making. The Feature Cloud platform for federated learning presents a comprehensive exploration of integrating domain knowledge graphs into deep learning for improved interpretability and explainability. Federated learning protects privacy, enhances data security and compliance, and promotes collaboration between devices. It improves the learning algorithm by incorporating explanations and conceptual knowledge for better interpretability. The platform addresses potential threats at each layer of the nested model, validating them accordingly. Regulations such as GDPR and European Union requirements for trustworthy AI are considered, focusing on ethical and technical requirements. The framework includes an expert-in-the-loop approach, ensuring human agency and oversight, and addressing technical requirements such as transparency, diversity, non-discrimination, and fairness. The research discusses the importance of GDPR and EU guidelines for trustworthy AI in AI development, focusing on the need for domain expertise and the use of knowledge graphs for ensuring fairness and robustness. It highlights the role of XAI techniques in transparency and the nested model for AI design and validation. The paper emphasizes the need for multiple iterations of the nested model and the importance of considering potential threats and validation methodologies. It also touches on the limitations of current regulations and the need for ongoing assessment and adaptation. The future work focuses on developing audience-centric XAI, prioritizing user needs and contexts, and ensuring compliance with legal and regulatory standards. The summary aims to provide a clear and concise overview of the research, highlighting key points and technical terms for a professional audience. Here is a combined summary of pages 13 and 14 of the research paper. The paper highlights the growing consensus on high-risk applications of artificial intelligence, AI, and international initiatives working towards harmonization. Key challenges include defining AI, balancing innovation with risk mitigation, and navigating international tensions. Despite these challenges, there is increasing political will for regulation, signs of transatlantic convergence, and the potential influence of EU regulations globally. Potential solutions include establishing global governance institutions, adapting best practices from other high-tech sectors, and developing open-source AI software. The authors introduce a nested model designed to facilitate international harmonization for AI regulations. The essential requirements identified by regulatory bodies in different countries may vary, but the underlying fundamental principle to satisfy these requirements remains consistent. The model aims to bring together disparate fields of AI and regulation, establishing a common baseline for designing and validating AI under the umbrella of regulation. The research is divided into 4 sections, examining the advantages of AI, the need for AI regulations, the potential of an audience-centric approach to AI, and the development of a nested model for AI design and validation. The XAI-QB, a question bank comprising algorithm-informed questions, is presented as a tool to assess and validate AI applications, fostering trust, faithfulness, and transparency. The nested model contains 5 distinct layers: regulations, domain, data, model, and predictions, with specific prototypical questions to be addressed at each level. The authors provide a comprehensive list of references, citing various studies and frameworks related to AI regulation, ethics, and governance. The research aims to address discussions around the need to work at the intersection of AI and regulation to increase adoption in high-stakes domains such as healthcare. By adopting the nested model for AI design and validation, the full potential of state-of-the-art AI techniques can be realized in a complex, interconnected, and globalized world. The research discusses the intersection of artificial intelligence, AI, and machine learning in software as a medical device, focusing on regulatory issues and challenges. It highlights the importance of explainability in AI systems, particularly in the healthcare domain. The authors emphasize the need for transparency and accountability in AI decision-making processes. They also discuss the role of human-in-the-loop integration with domain knowledge graphs for explainable federated deep learning. The summary touches on the ethical considerations and regulatory frameworks for AI development and evaluation, including the European Union's General Data Protection Regulation, GDPR, and the US FDA's guidance on AI in medical devices. It concludes by emphasizing the importance of multidisciplinary approaches to ensure the safe and trustworthy development of AI systems.